This video will provide an overview of the MMC 3D Analysis Python add-in and how to install it for use in ArcGIS version 10.1 or later. This Python add-in was developed for the MMC Production Team by Gannett Fleming. An Esri Advanced License level and the 3D Analyst extension are required for use of these tools. The .esri add-in is the only file necessary for the install. It can be saved anywhere on disk. Once it is saved to your desired location, double-click the file through Windows Explorer. After clicking the Install Add-in, the Install utility copies the add-in to your default add-in folder. Once an add-in has been installed, open ArcGIS, and the add-in is shown under the Add-in Manager, accessed from the Customize menu. To add the toolbar, right-click and check MMC 3D Analysis Tools. To use the tool, you need to verify that the 3D Analyst and MMC 3D Analysis Tools extensions are checked. Once these extensions are checked, the individual tools will become active once certain data types are added to the current map, and you are not in an ArcMap editing session. The data frame and the data used in these tools must have a projection defined with vertical and horizontal units in US feet. The toolbar is compiled of 6 different tools to aid in bathymetric surface development and overall 3D analysis. Open the Configure Settings dialog to enter values that will be used for some of the tools. I will explain each of the parameters in more detail later. The surface layer drop-down list is populated with surfaces found in the table of contents. The surface selected will be used for the digitized 3D lines and calculate slope tool. Possible surface types include last datasets, rasters, terrains, tins, and mosaic datasets. The digitized 3D line tool will create a 3D line by interpolating elevations from the selected surface layer in the drop-down list. The Weed 3D line tool will weed a single feature from a 3D line layer based on the tolerances set under the Configure Settings dialog. Label 3D line tool creates a temporary point layer labeled with elevations of vertices along a selected 3D line layer in the table of contents. The Identify Measure Elevation tool creates a temporary point layer with the measure and elevation labeled along a feature. Calculate Slope tool allows the user to digitize a line and return calculated slope values based on the surface layer in the drop-down list. Plot 3D Line tool will plot a graph of selected 3D lines in the map document. Lastly, there's a Help button which will link to a more detailed description of each of the tools and specific requirements. Now I'll go back to explain the Configure Settings button where a user enters settings that will be used for some of the tools. Enter a tolerance value for weeding of 3D lines. This will be the initial vertical and horizontal tolerance used for weeding of a 3D line. Enter a maximum number of vertices that you want to remain in the feature after weeding is applied. If you do not want more than 500 vertices, enter that value. Based on the maximum number of vertices entered here, the tolerance may increase so that number of vertices does not exceed this number. Input the desired number of decimal places that will be returned as labels in the Label 3D Line and Identify Measure Elevation tool. This is an option to display a profile plot when using the Digitized 3D Line tool. If this box is checked, a new window displaying the plot will open immediately after a line is digitized. It will compare the feature before it was weeded and after based on the weeding tolerance. There is an option to reverse the direction a measure is calculated along a line when using the Identify Measure Elevation and the Plot 3D Line tool. By default, the measure is calculated starting from the beginning of a line. An example of when you may want to check this option would be in cases when you are using the Identify Measure Elevation tool along a stream center line. It would be beneficial for the measures to start at 0 at the downstream end of the line. This is under the assumption that your line is digitized in the direction of flow. For more details on how to use the interactive 3D tools in ArcMap, watch the individual tutorials posted under this YouTube channel.